Arduino. This is Sean McGowan doing my submission for my final lab project, Lab 9. For this lab, I was inspired by the homemade Spider-Man suit that they use in Marvel's Spider-Man Homecoming. If you haven't seen it, I'll put a link in the description to show what I mean. I was inspired by the eyepieces, which were made with adjustable lenses to close and open the eyes. I thought, well, that uses motors, aka actuation, sensors, and I could build it and code it with an Arduino and simulate how it would work and look in processing. So I went ahead and made this my final project lab. In this video, I will explain my Arduino and processing codes. I will explain and go over how I constructed the eyepieces and the circuit which controls them, and then finally I will show it in action. So with that, we'll get right into it. For my Arduino code, I kept it relatively simple. I have my photoresistive sensor input into pin 2, and I would send the string of data from the Arduino to processing. I also have a variable for potentiometer input I planned on using in the future for more advanced iteration of the project. I then print the string and the input from pin 2 for debugging purposes. Then I have two for loops to control the servo motor on each eye from the light sensor input. The motors are flipped on each eye, so the down position on the left motor is the up position on the right motor. I mimicked the code I created from the servo lab earlier in the semester, and through trial and error, I was able to find the best duty cycles that worked. For my processing code, I have it set to read the string of data that is sent from the Arduino. I then have it separate the light sensor data into a variable A1. Next, I have two large if loops, one for the eyes being open and one for the eyes being closed. In each if loop, I make a red background, which is typical for the Spider-Man mask, and then I drew a circular outline and white interior circles for the eyes. I then learned and used the arc command to best represent the moving and stationary shades on the top, outside, and bottom of each eye. With a lot of trial and error and fine-tuning, I was able to have processing display the position of the moving eye shades in real time. I also added a little sun in the top right corner when the light sensor is detecting light to help notify which setting is being displayed. So for the construction of each eye, I started off using a plastic placemat and cutting out the shapes for the eye shades that I used in the project. I used a plastic cup to house the motor and the parts, and for the moving shades, I used two separate cutout pieces from the placemat, one to move lower and one that stays a little higher to cover any blank spaces. This was accomplished by attaching the stems of the pieces I cut out at different points on the servo arm, so one would move further down and one would move less. Lastly, using a lot of hot glue and Velcro to hold the motor and parts in place, I then repeated the process for the other eye. For the circuit, I had the servo signals from the PWM pins 9 and 10. I had all the servos powered by the Arduino because they weren't under any real load or stress, so it should have been fine. I then had a voltage divider with the light sensor and a 1000 ohm resistor to detect the change in resistance in the sensor. Lastly, here's all the work put together. I used an iPhone flashlight to activate the light sensor at different speeds for different amounts of time, and my processing window in the bottom left is showing what's happening in the real world in processing. But that is it for the project lab. I hope that this project shows some of the content I have learned over the semester, and it was really fun to bring something I've seen in movies and make it in the real world. Alright, that is it for the lab. I hope you enjoyed, and I'll see you soon.